Welcome to Cheenta Statistics and Data Science. Today we are going to solve this problem from ISI MStat year 2005, problem number 5 from the PSB section. Now the problem says that suppose x and u are independent random variables with probability x is equals to k is equals to 1 by n plus 1 for k 0, 1, 2 up to n, and u having a uniform distribution over the closed interval 0, 1, and let y is equals to x plus u. Then for y belongs to R, find probability y less than equals to y, that means the CDF of y, right? And find the correlation coefficient of x and y. Now, it's given that x follows discrete uniform over this set 0, 1 through up to n, right? 0, 1, 2 up to n, and u follows the uniform distribution over 0, 1. Now, it's given that x and u are independent and y is equals to x plus u. Now, obviously, the minimum value of x is 0, clearly is 0, and the minimum value of u is also 0. That means the minimum value of x plus u, that means y is obviously 0, that means y is at least 0, and the maximum value of y is when both x and u are maximum, that means when x is n and u is 1. That means y lies between, clearly y lies between 0 and n plus 1 inclusive, obviously, because y can attain these values. Now y can be written as u if x is equals to 0, right? Because y is x plus u. So if x is 0, then y is equals to u. If x is 1, then y is u plus 1. If x is 2, it's u plus 2, and so on. If x is n, then y is u plus n. We need to find the CDF. Now, probability y less than equals y is nothing but we're just taking the law of total probability. Since x is obviously going to be some value, right? It's going to take some value between the 0, 1, 2, and n. So the sample space can be partitioned into these n plus 1 sets. So probability y less than equals y can be written as probability y less than equals y intersection x is equals to 0 plus intersection x equals to 1, and so on, intersection x equals to n. Now the first one, if x is equals to 0, then obviously y is u, as we have just said. So that means it's nothing but probability y, probability u less than equals y, and x is equals to 0. Again, this one, if x is equals to 1, then y is u plus 1. That means just replacing y by u plus 1, we have probability u plus 1 less than equals y, and x is equals to 1. Again, for x is equals to 2, we have y is equals to u plus 2. So just replacing those things, nothing, just using this particular uh, idea we just did right now, and replacing case wise analysis. If y is equals to 0, then y is equals to u. If it's 1, it's u plus 1. If it's 2, it's u plus 2, and so on. Just replacing all of this. Now this can be written as, since u and x are obviously independent, it's been stated that u and x are independent. Now we can just split out the probability, we can distribute the probability. So now it's probability u less than equals y into probability x is equals to 0 plus probability u less than equals y minus 1 into probability x equals to 1, and so on, just doing this stuff. And these things are obviously, we know it's 1 by n plus 1, so just taking it out of the expression, I mean just taking common from it, we have 1 by n plus 1 times this one, probability u less than equals y plus probability u less than equals y plus y minus 1, and so on, probability u less than equals y minus n. So we can written as in a compact form as 1 by n plus 1 into summation r running from 0 to n, probability u less than equals y minus r running from 0 to n, right? Now, as a PDF of u is this, and the CDF of u is this one, right? So I've just written so that it just a bit clear, it remains a bit clear. Now probability u, this particular expression, let us see as an example for this particular expression, in this entire thing, this thing. First, notice that if y, this particular y, if it is lies between 0 and 1, if it lies between 0 and 1, then y minus r obviously is negative if r is 1, 2, or anything like that, right? Because since y is obviously less than 1, so if it's y minus r is strictly negative, right? It is negative. That means only this one is actually y, because obviously I just stated that this, the CDF of u is this one. So the entry, the enter if u, the point we have entered in the CDF, if it lies between 0 and 1, it returns u. Otherwise, if it's less than equals 0, then it's 0, and if it's greater than equals 1, it's 1. So if y lies between 0 and 1, then it's this one is just returning that value y, and others are 0, right? Others, this part, this is all 0, because this is this part y minus 1 becomes less than 0, so obviously it's 0. Again, this is also less than 0, so again this is 0, and so on. Now if y lies between 1 and 2, if y lies between 1 and 2, then y minus 1 lies between 0 and 1, and others, that means y minus 2, y minus 3, they are all negative. That means this part becomes 1. Why? Because y already is greater than equals 1. So obviously this part is 1, and this part is this one. This part is y minus 1, and others are 0. So ultimately the sum, see, 1 plus y minus 1 plus others are 0. That means the sum is again y, right? The entire sum, this, for this part, if y is 0 lies between 0 and 1, the entire sum is just y. Again y lies, if y lies between 1 and 2, again the sum is y. So we have just noticed a pattern. I have written this just to notice a pattern, just to make you notice the pattern of this sum. So in general case, suppose if y lies between m and m plus 1, this one, then y minus m obviously lies between 0 and 1, and probability y, probability u less than equals y minus r is actually 1 if r is less than m, y minus r if r is equals to m, and 0 if r is greater than m. So just r, that means the entire sum is nothing but y, because there are exactly r times 1, and this, there is that, then there is y minus r, and then there is 0. So ultimately just taking all the sums, we have y. That means probability y less than equals y is 0, obviously, because y lies between 0 and n plus 1. So obviously if y is less than equals 0, that means the CDF is obviously 0. And if it lies between 0 and n plus 1, it y by n plus 1. And if y is greater than equals n plus 1, then y, then this CDF is 1. That means y is nothing but the uniform distribution over 0 to n plus 1, right? So we have already found out the CDF. It's asked to find out the CDF in the first section, first problem, and then the correlation. The correlation is actually really easy. The correlation of xy is nothing but the covariance of xy by the standard deviations of x and y. The covariance of xy is nothing but variance of x. Now this is nothing but variance of x, because this part is 0, because obviously x and y are independent. So covariance of xy is nothing but variance of x. Now the variance of x has been calculated. It's very easy. It is discrete uniform. So variance of x is n squared plus 2n divided by 12, and the variance of y is n plus 1 whole square by 12. So the correlation of xy is nothing but root over of variance of x by variance of y, and this is root over of n square plus 2n divided by n plus 1. This is the answer. This is the second answer to the second part of the question. So this is a subjective question, obviously. As you can see, there are no options. So you have the solution right now. It's very easy. The only thing you have to do is just this piecewise breaking down of the random variables and taking this part. Only the important part is this breaking down of the this y's. You have to take the case wise to see the pattern, and once you have seen the pattern, you can just then do a general case, and you can clearly understand what's happening, and the entire sum becomes y, and so the CDF just becomes like this. That's the only thing. And the second part is very easy. As soon as you discover the distribution of y, it's very easy to calculate the variances, and also it's very easy. And second part is very easy, right? So there you have it, the solution to this problem. See you.